have to know about analytical geometry is that it's all about coordinates, and coordinates normally on a Cartesian plane. Okay, so we need to know the different quadrants because they're also quite important. Okay, we need to know certain things about all the numbers that fall into each quadrant. Now, in mathematics, we call this one over here quadrant 1, or we write the Roman numeral for 1. This is quadrant 2. This one down here is quadrant 3. And this quadrant over here is quadrant 4. And if you guys look in these little, just do that. There we go. If you guys look in the little blocks, the yellow, blue, and green and purple block, you'll notice that in quadrant 1, both your x coordinate and your y coordinate are going to be positive. Because if you look over here, all my x coordinates are positive and all my y coordinates are positive. So we're going to get positive coordinates everywhere. In this quadrant, however, in the second quadrant, my x coordinates will all be negative and my y coordinates will be positive. In my third quadrant, both my x and my y coordinates will be negative. So I have a negative x coordinate and a negative y coordinate. And down here in the fourth quadrant, I'm going to get a positive x coordinate, but a negative y coordinate. And that's just because of the way it's set up, the way it's broken up into the x axis and the y axis. Okay, this is something quite important to remember. And I'm going to assume that we are all comfortable with finding coordinates. Like, I'm going to ask you guys quickly in the chat, if you can drop for me, what is this coordinate over here? How would I write the coordinate of this green dot that I've drawn over here? How would I express that in coordinate form? You guys can drop that answer in the chat for me. Well done, Ethan and Danelle. Angela, just check again. Good stuff, guys. Well done. Good. Dinswalo, be very careful. Okay, so remember, guys, when we write coordinates, we always write the x coordinate first and then the y coordinate. Right? So we're always going to take this down to the x-axis and we'll find that our x coordinate is -1. And then we'll take this to the right to our y coordinate and we'll find that is 2. And then we always express it with brackets on each side. And that's how we get -1 and 2. Lwazi, do not forget your brackets. They're very important. They show us that it's a coordinate. Okay. All right. So we're all quite comfortable with this. So we're going to be looking at plotting these to reveal a shape. And a lot of analytical geometry, and I think I'm showing you guys the answers on my word. I need to move them over a little bit. A lot of analytical geometry is based on shapes. Quite a bit of it has a lot to do with shapes and lines. So I'm trying to hide the answers, but I feel like I've already shown you guys the answers. So Emilio, don't even. All right, guys. So if we plot these, what are we going to get? What kind of shape are we going to get? Can you guys let me know? Or at least take a screenshot so it doesn't look like we've cheated. Emilio, I'm watching you. Okay, so if we look at the first one, it might be a rhomboid. We'll have to look, Lashandra, let's see if I've got -5 and 1. And I've got -1 and 4. And then 5 and 0. And 1 and -3. Not quite a rhomboid. Because the other sides are a lot longer. So we could say this side and this side are not parallel. Can't say that. We could say that these two are equal, but then these two are not equal to the others. They're a bit too long. So we could maybe say that these two are equal. There we go. Yes. Yes, it's going to be a parallelogram. Well done, Yasha. It's a parallelogram. And we can see that from the way the shape is kind of slanted to the side. Okay. All right. And then if we go down here, I think the number of points you have can already kind of tell you what kind of shape you're going to get. Okay. Give me a second. Okay, so if we plot these over here, I'm going to go to 2 and 4. -4 and -2 will be down here. And 0 and 5, or -5, sorry, is over here. So this one particularly, this one is quite easy. We can see what shape this is. This is a triangle. We're not quite sure whether it's a right-angled triangle, but can we guess? We don't know that it's a right-angled triangle, but if it's not, what kind of triangle would it be? Let's classify it a little bit more. Now, this will determine whether we remember our triangles. Yes, Sipokazi. And you spelt it correctly. Well done. Oh, no, it's not isosceles. No, it's not. It couldn't possibly be isosceles. Guys, an isosceles triangle would look like this. And those two angles would be equal. And this one and that one would be okay. Yes, Imange. And Eunice. And Buche. And Kabi. Yes, it's not isosceles. It's going to be scalene. Does anybody remember what scalene means? What does scalene mean, guys? Emilio, at this point, I feel like you're just guessing. You're just going with the rest of the class as they answer. Does anyone remember what scalene means? Good, Ethan. Yes, none of the sides are equal and none of the angles are equal. So nothing is equal. That's how we say it. We just say nothing is equal. Nothing at all. Good, guys. I'm glad we remember. Okay, we're going to do one more. Okay. And remember, guys, a lot of this is going to come up when we're doing analytical geometry. Okay, what kind of shape will we get if we plot this? Okay, if I get 1, -5, all the way down here. 1 and 4. -3 and 2. No, that's -3 and 2. Yes. Okay, and then -3 and -3. Okay, so if I join these, okay, what kind of shape do I get here, guys? This is not a rhombus. No, it's not. Yes, Dineo. Good. This one is a trapezium or a trapezoid, depending on how you call it. All right, good. It's a trapezium or a trapezoid. I'm used to calling it a trapezoid rather than a trapezium. Okay. That's okay. All right. Okay, so we can use coordinates to make shapes and to put two lines together to make a long line. And we're going to be learning about how to put these kind of things together. And there are a couple of things that we're going to have to look at as we're going. The first thing we're going to learn about in analytical geometry is the distance formula. Okay, now what the distance formula does is it gives me the space between, or the length of the space between two coordinates. So if I had to calculate the length between A and B, so if I had to calculate this length over here, what I would then do is I would take the formula, which comes from Pythagoras, actually, if you think about it, okay? And I would take the X value It does not. No, it does not. Okay, so I'm going to choose which one is which. Okay, I'm going to say that this one is x1 and this one is y1, not x1. I'm going to call 5x1 and 7y1, and I'll call 2 over here x2 and 3y2. So when I put it into the formula, I'm going to take x2, which is 2, and I'm going to minus x1, which is 5, all of that squared, plus y2, which is 3, minus 7, which is y1, and all of that squared. Now, if I punch that into a calculator quickly, I'm going to get 2 minus 5 will give me negative 3. That's 9 plus 3 minus 7 is negative 4 squared will give me 16. And this will give me the square root of 25, which is 5 units. I'm going to say units. Angela, does it matter which one you label as x1 and y1 first? No, my sweetie. Angela, it doesn't matter. However, I can't decide that I want to swap these two around. So I can't go, this is x1 and this is y2, and this is x2 and y1. That I can't do. If I start with the x's up top here, if I start with x1 over here, my y1 must also start over here. Okay, we're going to do another example just now. Ayanda, hold on for me. Okay, so if I choose that this is x1, then my y value must also be y1. I cannot change it and make the other one y2. They need to both come from the same place. Okay, Ayanda, we're going to follow the formula quickly. Have a look at the formula that we've got written up here in this little bubble that we've got over here. So it says that d is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared, or y2 minus y1. It doesn't matter. Gelita says, does the answer always have to be positive? Yes. And the reason for that is because we're calculating a distance. And I, in my life, have never heard of a negative distance. You cannot walk a negative distance. Like, I can't say I walked minus 50 meters. That is not possible. It's not possible for you to walk a minus distance. It's always going to be positive. Okay. And the reason why you will always get a positive answer is because we're going to square the numbers. And anytime you square a negative number, it just comes out positive. Okay, I'll show you here. I feel like I skipped a step. Okay, hold on. Okay, so if we look at the answer over here, 2 minus 5 is going to give me negative 3 squared, plus 3 minus 7 will give me negative 4 squared. Now, negative 3 squared is going to be 9, positive 9, because it's like negative 3 times negative 3. So that'll be 9, plus negative 4 squared will give me 16. And that's how our answer ends up being positive. Bonolo, do you have a question?
Yes.
Hi, Bonolo, how can I help?
Ma'am, I would love to ask, is it a must to write units if there's no meters or centimeters?
Yes, and the reason why I want you to get used to that is because we're calculating a distance, and a distance will always have a unit. Okay, it will always have a unit of measurement. So if they don't give you one, I suggest you just write units anyway. Okay.
So if you don't write it, it's wrong.
I don't particularly think it's wrong, but you're always going to find that one teacher who's like, no, I want a measure of, like a unit of measurement. So you don't want to be in a place where you don't write a measure, but the teacher that's marking actually wanted one.
Thank you, ma'am.
Okay, sure. You're very welcome. See, Emilio had that kind of teacher before. My maths teacher in high school was also like that. He wasn't a very generous man. Okay, so if we had to calculate the length of CD, let's calculate the length of CD. CD, that's going to give us the square root of, and we're going to choose which one is x1 and y1. We'll choose that. So I'm going to say C over here. I'm going to label that x1 and y1, and I'm going to take D and I'm going to label it x2 and y2. So when I go into my formula, I'm going to look for x2, which is -2, minus, and then you'll notice here that x1 is -5. So I'm going to get minus -5. That's going to give me a positive squared, plus my y value at y2 is 1, minus my y value at y1 is 6.
Okay.
1 minus 6 all squared. Yes, ma'am.
Please close the other brackets because it looks like you're squaring the -5.
Oh, sorry. There we go. There we go. Another bracket there. Yes, Teacher Cat. Thank you. Thank you, Teacher Cat. Okay, so we're going to clean this up a little bit. Okay. Do this the long way. So -2 and -5 will give me +5. -2 plus 5 will give me -3. All of this squared plus 1 minus 6 will give me -5.
Teacher
all
Coco,
squared. Yes, ma'am.
-2 plus 5 is +3.
+3. Oh my goodness, where is my brain today? Thank you, Teacher Cat. Sorry for that. Sorry for that. Sure. Okay. If Teacher Cat wasn't here, I wonder what I would do. Thank you. See, Atemba's already got the answer for us in the chat, so we can clean this up. 3 squared is going to give us 9, plus the 5 squared, or -5 squared, will give us 25. I think you're off by just a little bit. This is going to give us the square root of 24. Now, the square root of 24. Oh, Lord. Guys, I don't know what is up with me today. 34. Thank you,
The brain has
Lashandra.
stopped functioning.
Sure. Today is just not my day. It's 34. It's the square root of 34. Now, the square root of 34 is not a perfect square. It's not like the square root of 25, where we will get an easy answer for that. Okay, so what we don't want to do is end up with a lot of decimals at the end. We don't want to end up, because the square root of 34, if I put it into my calculator, it'll give me like a lot of decimals at the end. So the square root of 34 is equal to 5,830951895. Now that's complicated. That's very complicated. And it doesn't give us an accurate answer, because the square root of 34 is actually an irrational number. And you don't want to round off unless they ask you for an answer in decimals, unless they're like, round off to 2 decimal places. You don't want to do that. So if they don't ask you to round off, please leave it as the square root of 34, because that's as accurate an answer as possible. But if they do ask you to round it off to 2 decimal places or 1 decimal place, then you can definitely do that. Okay, I hope that's understandable. So I'm going to give you some time to practice. Hopefully your maths is better than mine. And while everyone else is looking at this, I'm going to take George's question quickly. Okay, so we're going to do A, B, C, and D. Okay, and once you guys have calculated all of them, please put this weird laughing man emoji, this weird smile emoji, just because I'm having one of those kind of days. That dude. All right, guys, I'm going to give everyone 5 minutes for this. Hi, Georgia.
Hi, ma'am. I wanted to
Hello.
ask, how did you get 9 plus 25 when it was a -5 and then squared?
Okay, so if I square -5, right? If I go -5 all squared, that's the same thing as -5 multiplied by -5. And a negative are going to give me positive, and then 5 times 5 will give me 25. And that's how we got positive 25. Okay, does that make sense? All right. Okay. Awesome. Just give you guys some time to get through that. Lashandre, please do all of them if you can. Let's do all of them. And then we can compare answers.
Hey,
Just remember to stay on mute, guys. Okay. Okay, I'm just going to write down the formula for you guys so you can remember. It's the square root of x2 minus x1 squared plus y2 minus y1 all squared. Okay. All right. Liasruma, did you get something similar to me? Then I'll ask you guys to give me your answers to 2 decimal places, if that will help. All right, I'll give you guys a chance to finish the rest and you guys will let me know when you are done. If you can just put the emoji in the chat for me, please. Thank you, Nati and Nolutando and Kabi. Thanks, guys. Okay, 1 more minute for those of you who are not done. Awesome. Okay, I'm going to start putting answers down. Here's the answer for C, or for B, sorry, question B, CD is equal to, choose x1, y1, x2, y2. Mm-hmm. Square root of 13. Why did I put a plus in the first bracket? What I was going to get over here is x2, which is 1, minus -2. So minus and negative, like a negative and a negative will give me a positive. So I'm going to end up with 1 plus 2. All of that squared. Okay, so I just skipped a step there. Maybe I should put all the steps down and not skip one. Okay, I hope that makes sense. Okay. All right, so let's look at C. C is mn, which is equal to the square root of, and I'm going to choose this x1 and y1, x2 and y2. So I will have -1 minus 2 all squared plus -3 minus 4 all squared. Plus -7 all squared is equal to the square root of 9 plus 49, which is equal to the square root of 58. And that is equal to the square root of 58 is equal to 7,62. Okay. And for the last one, D, I'm calculating for OP is equal to the square root of, and I'm going to name this one. I just cannot see, guys. My camera is blocking me here. X1 and Y1 and X2 and Y2. That will give me -2 minus 0, not plus. -0 all squared plus 4 minus 0 all squared is equal to 4 plus 16, which is equal to the square root of 20. And that's equal to 4,47. And I've left out the units everywhere. Units. All right, guys, mark out of 4. How much did you guys get? Out of 4, how much did we get? Well done, Kabi. Emilio got 2. Sure, Emilio, I hope you see where we didn't quite go. Okay, excellent, guys. Yes, I'm wondering who's saying, so I was right. Yes, Pamela, if you got the correct answer, that means you were right. Leah Khuma, if you were lost, remember you can ask a question. Okay. If you're a bit lost. Guys, if you got 3 out of 4 and you didn't quite get 100% for this, I hope you guys are seeing where you didn't quite get the correct answer and why. Okay. All right, this is great, guys. Awesome. Okay, so we're going to be learning about the midpoint in the next lesson. I think we can have a couple more practice rounds for this one. That's not the one I'm looking for. This is the one I'm looking for. Okay, so we're going to be looking at this. Okay, so it says here, in the diagram, the vertices of triangle ABC are A, B, and C, and they give us the coordinates. Show that ABC is an isosceles triangle. Now, can anyone remind us, guys, what is an isosceles triangle? Isosceles triangle. Yes, Marcelo. What is an isosceles triangle?
Ma'am, an isosceles triangle has 2 equal sides and 2 equal angles. Good.
Okay, excellent stuff. All right, so we're not going to be able to do much about the angles because we don't have any angles. They haven't given us any angles. But if we want to prove that this triangle is isosceles, then we're going to have to show that two of these sides are equal. Does anyone have any idea how are we going to approach this? What do you guys think? What do you guys think we can do? Masego, I know you know the answer. I have no doubt. I want to see if anyone else has an idea on what we can do. Anyone else? Okay, Masego, are you gonna let us in on the secret? I was hoping somebody else can see.
Yes, ma'am. We're gonna use the distance formula or any other, but we're gonna, in this case, the distance formula, and we're going to prove that two of the sides are equal, basically. So, yeah,
Which two
basically. So then
though?
we're gonna see, ma'am, because we're gonna use any of the sides, and then if any two sides are equal, that it means it's gonna mean that it is an isosceles triangle.
Excellent, well done. All right, that's exactly what I wanted to hear. So I can't just calculate for two sides and then when I get there and I find that they're not equal, I'm like, oh no, it's not isosceles. I'm gonna have to calculate for all three of the sides and see which two of them are equal. So my three sides that I'm gonna calculate for are A, B. I have to find A, B. Another side I can calculate for is B, C. And another side I can calculate for is A, C. So I'd like you guys to calculate for those three sides for me and put the answers that you get in the chat for me, please. Please do not round off in this case because your decimals might be off. Okay, just if the answer is the square root of a number that is not a perfect square, please don't write it in decimal form. Leave it as a square root. Okay, I'll give you guys 2 minutes or 3 minutes, so 1 minute per question to see if you can figure this one out. For those of you who don't remember the distance formula, the square root of x2 minus x1 plus squared, sorry, y2 minus y1 squared. Okay. Sure, Ethan, that was fast, like very, very fast. But we're going to wait for everyone else and see if everyone else finds the same answer. So just write for me, AB is equal to this and BC is equal to this. Thank you, Kasakile. I see your answer. Thanks, Ethan, for all of those. I just want everyone to get a chance to actually figure out how they got there. Okay. For those of you who said AB is 5, well done. Let's work out the others. BC is 5 root 2. Okay. I see how your calculator would do that. Yeah, but that's about correct. Okay. I think we need to go the long way for that one though. Plus 6 minus 7 squared to the square root of -7 squared plus 1 squared. 49 plus 1, which is equal to the square root of 50. So for those of you who are getting 5 root 2, that is probably because your calculator is is rationalizing for you. And you guys don't do rationalization in grade 10. So what you're going to have to do to get your marks is actually show all of these steps. Okay. So if you end up with the answer 5√2, that means you punched everything into your calculator and this is the answer you got. We're not very interested in getting that the answer is 5√2. What we need to see is the square root 50 over here. Okay, that shows us that you went through all the steps properly. Okay, I hope that makes sense to you guys. Okay, and then we're going to calculate for AC. It's equal to -2 minus 2, sure, squared plus 6 minus 3 squared, which is equal to the square root of -4 squared plus -3, or +3, not -3. I caught myself this time. 3 squared, which is equal to the square root of 16 plus 9, which is equal to the square root of 25, which is equal to 5. Okay. All right, guys. Have we proven from this that this is an isosceles triangle? Yes or no? Good. All right, good. The answer is yes, 100%, because AB is equal to side AC, and that tells us that it is an isosceles triangle. Therefore, isosceles, that's how I remember how to write it, isosceles. Okay, excellent. So now question B says, calculate the perimeter of triangle ABC correct to 1 decimal place. Okay, give me 1 second. This is going to give us 7,07, I believe. Okay. Yes, Bonolo, how can I help? Hi, Bonolo. Hello. Bonolo, you can ask your question. Oh, no. I don't think her mic is working either. Hi, Bonolo. Sure. Okay. Bonolo, I need you to check your mic setting, please. Okay, because we're having quite a lot of trouble hearing you. Okay. All right. Okay. So how would we calculate the perimeter, guys? How would we calculate the perimeter? Ethan's got it. Sure. Excellent, Ethan. Can you put up your hand and explain to us, or tell us in the chat, how did you get the answer for that? Good, Georgia. Yes. Okay. Now, perimeter is square root 25 plus square. Okay, no, we don't need to use the square roots, Ethan. Okay, we're just going to take all the numbers and we're going to add them together, just like what Georgia says. So we're going to take side AB plus side BC plus side AC. And how much are we going to get for the perimeter? Because it does say, calculate the perimeter correct to 1 decimal place. Okay. So I'm actually going to make this, rather than 0.07, I'm going to make this 7,1. Good. Correct to 1 decimal place. So this is going to give us 5 plus 7,1 plus 5, which is equal to 17,1 units, we can say, because they don't tell us the units. Okay,